Okay, so now today we will start with our fourth unit. Okay, so unit 4. It is unit 4. Center of gravity. Center of gravity and moment of inertia. Moment of inertia. So this is our fourth unit, center of gravity and moment of inertia. Okay. Actually, we are using this concept. Okay. See, whenever we were dealing with the numericals of the friction. Okay. Whenever we deal with the numericals of friction, you have seen these types of numericals that inclined plane was there. On this inclined plane, a body is moving. Okay, on this inclined plane, a body is moving like this. Okay, and this plane is inclined at an angle theta something. So the self weight of the body, you consider it from the centroid of the body. Okay, the weight W is acting from the centroid of the body. Centroid means there are two terms, centroid and center of gravity. If the body is 2D, if the body is having only two dimensions, likewise if I consider a rectangle. Okay, now see, if I consider here this paper, okay, this paper. So you can see this paper is having two dimensions. Its third dimension, that is thickness, is very less. It is nearly equal to 0. It is very less. It is nearly equal to 0. So you can see that paper is 2D paper. It is not a 3D paper because third dimension it is very small and it is tends to 0. Okay, so such a 2D figures, when we refer to such a 2D figures, then the centroid of those 2D figures, and then where is the center of these 2D figures? It is called as centroid. Okay, it is a point through which we assume that the area of that body is acting on the ground. And center of gravity, it refers to 3D figure. Okay, a solid sphere or maybe other solid hemisphere, that type of figures are there. For that, we use this word center of gravity, which is having 3 dimensions. So center of gravity is a point through which we assume that the weight of the body is acting to the ground. Now, as a human being, now we are having 3-dimensional. Our body is 3-dimensional body. Okay, and we assume that our weight is acting from the center of gravity of our body. Okay, so although the weight is acting through every part. Now suppose if I put my hand on the table, some weight is acting through the hand. If I'm sitting on the chair and if I'm sitting on the chair or if I'm standing, then also some weight is acting, okay, through legs and all the body parts. But for the analysis purpose, we assume that the weight of the body is acting through a single point. The weight of the body is acting through the single point, and that point is called as the center of gravity in 3-dimensional cases. Okay, in 2-dimensional bodies, we don't consider weight, we consider area. For 2-dimensional bodies, we don't consider weight, we consider area. And that point is called as centroid. So centroid is a point from where the whole area of the body, we assume that it is acting through that point. Okay, so first of all, we will write down the definition and then we will see it in detail. What is centroid and center of gravity? Okay, so once we write the definition, it will be clear to you. What does it exactly mean? So first definition is centroid. First is the centroid. So the definition is the point at which total area of the plane figure, total area of the plane figure is assumed to act, is assumed to act, is known as, is known as centroid, is known as centroid. Okay, simple definition. The point at which total area of the plane figure is assumed to act. Okay, this is the point through which the total area of the plane figure is assumed to act. Now suppose now if I draw the rectangle. Okay, draw the rectangle. Okay, this formula we have seen already for the rectangle. Suppose now this dimension of the rectangle is B and this dimension of the rectangle is D. This dimension is B and this is D. Okay, so centroid is situated somewhere here. B by 2, D by 2. I have already told you this formula. In the case of UDL, when we convert the UDL into the point load, we take that point load at the center of the UDL, at the center, that is whatever the length of the UDL center. Why it is at the center? Because it is a rectangular load and its formula is B by 2 and D by 2. So this is B. Now this is the point where we say that the area of the diagram is acting. Okay, from this point, area of the diagram is acting. Okay, area of the diagram is acting. So this point, it is known as centroid. So this point, it is called as centroid. Is it clear? What is the centroid? तुम्ही बघा जेव्हा आपण युडीएलचं पॉइंट लोड मध्ये कन्व्हर्जन करतो की नाही किंवा युव्हीएलचं पॉइंट लोड मध्ये कन्व्हर्जन करतो आपण काय करतो युव्हीएल असल्यावर ट्रायंग्युलर लोड असल्यावर we take half into base into height, we take area in the consideration. Okay, so centroid is the point through which area is acting, and that area is nothing but our magnitude of the point load that we take in the second unit, if you remember. Okay, so the point through which the total area of the body is acting. Now what is the area here? Area is B into D. Area is B into D. That is why when you consider say that this UDL is a rectangular load, suppose this is 10 kilonewton per meter and this is 5 meter, how you take the point load? The point load which is acting, it is 10 into 5. 10 into 5 is nothing but area, and this load you take it through the centroid. As a point कुठला असतो centroid ते या concept मुळे. The concept is this concept. Okay, the concept is we assume that the total area of the body is acting through the single point, and that single point is called as the centroid in the case of two-dimensional figures, that is plane figures, which is having only two dimensions. Is it clear? Yes, no?
Yes, sir.
समजलं ना व्यवस्थित?
Yes, sir.
Okay, so this is the centroid, first definition. Then second definition we will see center of gravity. Concept is same, just in the centroid we consider total area. Okay, and in the center of gravity we consider weight. In center of gravity we consider weight as it is three-dimensional figure. So here center of gravity. So center of gravity, the point at which whole weight of the body, whole weight of the body, whole weight of the body is assumed to act, is assumed to act, is called as center of gravity. is called as center of gravity. So from the center of gravity, the weight is acting. Okay, just 1 minute. Synopsis रोहिणी चव्हाण बघितलंय का सगळं मी चेक केलं नाही दोन साईड आहे तुमची MM4 तर गाईड आहे तुम्ही तर एकाने चेक केलंय का आपल्यापैकी कोणतं करला सही घेऊन झालं काय तसं नाही काय जर आपलं चुकलं असेल तर प्रॉब्लेम असतो तर देशमुख सरांनी केलं हा मग ठीक आहे तुम्ही तर एकाने बघितलं असेल म्हणूनच देशमुख सरांनी दिलाय असं आहे क्लास जेव्हा जे जे त्यांचा पण साहेबांना वर्षा साहेब माझी बादशी मुली वरण काय मग मला लगे फाशीच कर तेवढं करून सगळं तुम्ही त्यांना थांबायला मला बाळा बाकीचे मोठे बाळ म्हणजे येते करून काय आपल्या विचारता येते सगळे एक तुमच्या दोन त्याच्यातल्या दोन असते एकाच माणसा माणसाची कमिटी कशी असते हो Okay. So the point at which whole weight of the body is assumed to act. See, in the definition itself, the word is assumed to act. Means we assume that the weight is acting like that. Okay. So that is called as the center of gravity. Okay. So now we will having some direct formulas for the centroid of the plane figure. So we will see some direct formulas. Mostly we are dealing with the centroids. We are having two-dimensional figures in our syllabus, and mostly we are dealing with the centroids, how to calculate the centroid and how to calculate the moment of inertia. About moment of inertia, we will study that later. First of all, centroid, this is the most important point, that is the centroid. So once again, I will tell you the point at which total area of the plane figure means two-dimensional figure, is assumed to act, okay, is known as the centroid. So area of the plane figure, so this is the area B into D. This area is acting through the single point. That single point is called as the centroid. Okay, that single point is called as the centroid. I have also given you the example of the UDL. In case of UDL, we are doing the same thing while converting UDL into the point load. How do we convert the UDL into the point load? 10 into 5. 10 into 5 is nothing but area of rectangle. UDL is nothing but rectangular load. One side is 10 kilonewton per meter, other side is 5. So L into B, 10 into 5. So ultimately we calculate the area. And this area, we say that this point load will act at the center of this UDL. Why at the center? Because of this centroid formula. The centroid of rectangle is at the center, that is at a B by 2 and at a D by 2. That is why we take that point load at the center in the UDL length. That is the reason why we do that. But in the second unit, you don't know this basic concept behind that. So that is why I have not briefly telling you by taking that example also, why we are doing like that. सो आय होप नाव की त्यावेळेला ज्यांना कोणा समजलं नसेल की UDL ला सेंटरलाच का घ्यायचं तर आता या चॅप्टर मध्ये तर तुम्हाला ते कळून जाईल. ओके, सो नाव दिस इज द सेंट्रॉइड. So is there any difficulty in understanding the centroid? Is there any point on which you want to ask the question or anything else is there? So shall I assume that you understood what is centroid and what is center of gravity? Or you really understand that now what is the centroid and center of gravity? समजलंय का काय सांगितलंय ते? सेंट्रॉइड म्हणजे काय आणि सेंटर ऑफ ग्रॅव्हिटी म्हणजे काय? किती जण आहेत लेक्चर अटेंड करायला गेले? 48 स्टुडंट्स आर देअर इन द लेक्चर. सांगा लवकर, बोला काहीतरी. तुम्हाला कळलंय का सेंट्रॉइड काय आणि सेंटर ऑफ ग्रॅव्हिटी काय? बिकॉज जर हे कळलं नाही, if you won't understand this basic, then there is no point in the further unit. You will not understand it, that in the further part you will not understand if you won't understand this. So if you say I will repeat it again, or let me know if you are understand this, then we will move to the next point. काय सांगा पटकन, समजलंय नाही समजलंय?
सर
काय म्हणताय?
सेंटर ऑफ
ग्रॅव्हिटी रिपीट करा ना.
सेंट्रॉइड समजलंय का?
येस सर.
येस सर.
हा, मग इथं सेंट्रॉइड मध्येच सांगतो बघा तुम्हाला, सेंटर ऑफ ग्रॅव्हिटी कशाला म्हणायचं. आता हा सेंट्रॉइड आहे, त्याला मी सेंट्रॉइड का म्हणतोय, कारण हिअर वी आर कन्सिडरिंग प्लेन फिगर. प्लेन फिगर म्हणजे रेक्टँगल. रेक्टँगल म्हणजे तुम्ही वहीचं एक पान इमॅजिन करा, a single page of your notebook. If you see the single page of your notebook, then it is having width, it is having depth, but its thickness is very, very less. But its thickness is very, very less. So I can say that the single page of the notebook is nothing but it is two-dimensional figure, because it is having only two-dimensional. Its third dimension is zero, nearly equal to zero. Although it is not zero, but almost it is zero. You can see the thickness of the page of your notebook. So those figures are called as plane figures. अशा फिगर्सला काय म्हणायचं? प्लेन फिगर्स. Now instead of, and the center of these figures, it is called as centroid. The point at which area of these figures is acting, that is called as centroid. मग आता सेंटर ऑफ ग्रॅव्हिटी म्हणजे काय? प्लेन फिगर्स नाही, त्याच्याऐवजी कुठले फिगर्स येणार? 3D फिगर्स येणार तुमच्या. ओके, इथं काय लिहिलंय बघा, द पॉइंट ऍट विच होल वेट ऑफ द बॉडी इज अज्युम्ड टू ऍक्ट, ओके, is called as center of gravity. Now here, if I add one more dimension, see now this is the rectangle, and now in this rectangle, if I add one more dimension like this, now it will not be the rectangle, it will become cube. It will become cube. So cube is having three-dimensional. Cube is having three dimensions. This is the back side. Okay. So cube is having three dimensions. So in the cube, you can say that the weight of the cube is acting vertically downward. So what we will assume that there is one single point in the cube. Here somewhere one single point is there in the cube. Through this single point, the weight of this cube is acting. Okay, the weight of this cube is acting. And that single point, this single point is called as center of gravity. This single point is called as center of gravity. When cube is there, you will say that the weight is acting and it is center of gravity. And if you remove its third dimension, then it will become rectangle. ओके, जर या क्यूबचं तिसरं डायमेन्शन तुम्ही काढून टाकलं, हे जे आपण आता एक्सटेंड केलेले ते, तर हा रेक्टँगल होईल. आणि सेम पॉइंट मधनं वेटच्या ऐवजी काय ऍक्ट होईल? एरिया ऍक्ट होईल. तर त्याला आपण म्हणतो सेंट्रॉइड. आणि जर अशी थ्री डायमेन्शनल फिगर असेल, तर त्याच्या या एका पॉइंट मधनं जर वेट खाली डाऊनवर्ड ऍक्ट होता असं आपण अज्युम करतो, तर त्या एका पॉइंटला काय म्हणतो आपण? सेंटर ऑफ ग्रॅव्हिटी. सो इन द केस ऑफ थ्री डायमेन्शनल फिगर्स, center of gravity is there. In the case of plane figures, we call the same point as a centroid. So for the plane figures, we will assume that area is acting through that single point, area for the plane figures. And for 3D figures, we assume that the weight of the body is acting. Okay, weight of the body is acting. So that point is called as center of gravity. Okay, is there any doubt still?
नो सर.
फरक कळला का सेंट्रॉइड आणि सेंटर ऑफ ग्रॅव्हिटी मध्ये?
येस सर.
नक्की कळलाय? पुढचा घ्यायचा पॉइंट?
येस सर.
ओके, एवढं लक्षात ठेवा, सेंट्रॉइड हे टू डायमेन्शनल फिगर्सला असतंय आणि सेंटर ऑफ ग्रॅव्हिटी हे थ्री डायमेन्शनल फिगर्सला असतंय. सेंट्रॉइड म्हणजे काय? की असा पॉइंट की ज्याच्यातनं पूर्ण बॉडीचा जो एरिया आहे तो ऍक्ट होतो. ओके, असा आपण ऍज्युम करतो फॉर अनालिसिस पर्पज. आणि सेंटर ऑफ ग्रॅव्हिटी म्हणजे काय? की असा पॉइंट त्या बॉडी मधला की ज्या पॉइंट मधनं होल बॉडीचं वेट ऍक्ट होतंय. ओके, त्याला म्हणतो आपण सेंटर ऑफ ग्रॅव्हिटी. आणि both of them are assumed because in the definition itself you will see that this word assume to act. Actually it is not like that, but we assume that for the analytical purpose, to analyze the structure we have to make some assumptions. So this is one of the assumptions. So now for your syllabus, there is no derivation. Some direct formulas are there for the centroid of the plane figure. So we will see some direct formulas how to calculate the centroid of the plane figure. Okay. While calculating the centroid, you must also remember that now suppose this is a rectangle. Okay. So centroid म्हणजे काय? To locate the centroid means what? Suppose here is the centroid. Okay. Now how you define the location of this centroid? How you define the location of the centroid? To define the location of any point. Suppose now, if I tell you a point A is there, whose coordinates are 2 and 3. Okay. Suppose point A is there, whose coordinates are 2 and 3. Then can you plot this point on the graph if the coordinates are given? अजून एक पॉइंट सांगतो, पॉइंट बी, इट्स ऑर्डिनेट्स आर 4 and 5. इथं हा असा y ऍक्सिस आहे. दिस इज y ऍक्सिस, दिस इज x ऍक्सिस. Here it is 0, then 1, 2, 3, 4 and so on. Here also 1, 2, 3, 4, 5, 6, so on. So I am having 2 points. My first point is point A, whose coordinates are 2 and 3. Now I want to plot that point A on this graph. What I will do? What is the procedure to plot that? काय करणार सांगा मला. माझ्याकडे हा A पॉइंट आहे, त्याचे ऑर्डिनेट्स आहेत 2 आणि 3. मला A पॉइंट या ग्राफ वरती दाखवायचा आहे. कसं दाखवू मी? काय करावं लागेल मला? झालेलं आहे ना तुम्हाला हे? कसं प्लॉट करणार मी A पॉइंट आणि B पॉइंट या ग्राफ वरती सांगा मला एकदा.
दोन हे एक्स ऍक्सिस वरच घ्यायचं आणि वाय ऍक्सिस.
बर, 2 हे एक्स ऍक्सिस वरच घ्यायचं. चला इथे एक्स ऍक्सिस वरती 2 मिळालं मला. आणि 3 हे कुठलं घ्यायचं?
वाय ऍक्सिस.
वाय ऍक्सिस आहे बघा, इकडनं वाय ऍक्सिस वरती 3. म्हणजे हे जिथं मीट होईल इथं मला काय मिळेल? पॉइंट ए. म्हणजे आता तुम्हाला दुसऱ्या भाषेत मी सांगतो, जर मला एखादा पॉइंट जर लोकेट करायचा असेल, जर मला एखाद्या पॉइंटची पोझिशन जर लोकेट करायची असेल, तर मला त्याचे काय माहिती असायला पाहिजे? ऑर्डिनेट्स. बरोबर आहे? व्हॉट शुड आय नो? ऑर्डिनेट्स. ह्याला 2 and 3 ला आपण काय म्हणतो? दीज आर कॉल्ड एज ऑर्डिनेट्स. जर मला एखादा पॉइंट हा प्लॉट करायचा असेल तर मला काय करावं लागेल? आय शुड नो द ऑर्डिनेट्स. ओके. सो फॉर द सेंट्रॉइड we assume that its ordinates are x bar and y bar. What are the ordinates of centroid? X bar and y bar. Okay. ही पहिली गोष्ट. दुसरी गोष्ट, मला जर हा A पॉइंट प्लॉट करायचा असेल, माझ्याकडे ऑर्डिनेट्स आहेत, तरी पण जोपर्यंत मला हे रेफरन्स ऍक्सिस जे आहेत ना एक्स आणि वाय, त्या एक्स आणि वाय ऍक्सिसची मी जोपर्यंत पोझिशन फिक्स करत नाही तोपर्यंत मला हा पॉइंट ग्राफ वरती दाखवता येत नाही. ओके. हे काय आहेत आपले एक्स आणि वाय रेफरन्स ऍक्सिस आहेत. तर हे जेव्हा एक्स आणि वाय आपण ऍक्सिस घेतो, एक्स आणि वायलाच तुम्ही रेफर केलं ना. हा 2 पॉईंट दाखवताना तुम्ही रेफर कुणाला केलं? एक्स ऍक्सिसला केलं. हा 3 पॉईंट प्लॉट करताना तुम्ही कुणाला रेफर केलं? वाय ऍक्सिसला रेफर केलं. सो एक्स अँड वाय ऍक्सिस आर आवर रेफरन्स ऍक्सिस. सो सेंट्रॉइड कसा दाखवला जातो नेहमी? तर ही जी प्लेन फिगर आहे, तर या प्लेन फिगर मध्ये दिस इज अवर वाय रेफरन्स ऍक्सिस. दिस इज कॉल्ड एज रेफरन्स ऍक्सिस वाय and this is called as reference axis x. This is called as reference y axis. This is x axis, and this x bar and y bar are measured from these axes. Okay. So what is x bar now? X bar is x coordinate, like that these 2 and 3 are there. Same way x bar and y bar is there for this centroid point. So from y axis, the distance of the centroid, whatever the distance of the centroid is there, this is the horizontal distance. So this is called as x bar. And from x axis, whatever the distance is there of the centroid, this is called as y bar. This is called as y bar. Okay, are you getting the point? Yes, no. इथं जसा ए पॉइंट तुम्ही प्लॉट केलाय 2, 3 सेम आहे इथं. इथं फक्त 2, 3 च्या ऐवजी मी म्हणलंय एक्स बार अँड वाय बार. एक्स बार अँड वाय बार. ओके, is it clear? समजते का नाही? काय हो नाही काय तर बोलत जावा. मला कसं कळणार पुढं काय काय करायचं नाही ते.
येस सर.
नाहीतर मग सांगत तर जावा, रिपीट करा सर, अजून एकदा सांगा, नाहीतर पॉइंट समजलाय. नाहीतर मग ते काय होईल माहिती का, मग मोनोटोनस लेक्चर होईल की म्हणजे ओनली आय एम स्पीकिंग, आय एम रायटिंग समथिंग, you are only listening and you are taking down the notes, that's it. Okay, so if you want that type of lecture, then you will not get much more out of that lecture. Okay, if the lecture is interactive, you are discussing something always in the lecture, then it will be fruitful to you also. You will get more points. Okay, so here you can see these are the reference axes. Similarly, I will consider this x and y as my reference axis. हा माझा कुठला पॉइंट आहे? हा आहे सेंट्रॉइड. ह्याचं जर मला लोकेशन दाखवायचं असेल तर मला ह्याचं एक्स बार आणि वाय बार हे कोऑर्डिनेट माहित पाहिजेत. जसं मी साधं एक्झाम्पल घेतलं, इफ आय कन्सिडर पॉइंट ए, 2 and 3 are my coordinates, means what? My x coordinate is 2. So from y axis, this distance is 2. This is 2. You can see you have measured this as a 2. So this is 2. And this distance is 3. This is 3 from x-axis, this is second ordinate. So second ordinate is your y bar. So this is nothing but this is your y bar. This is your first ordinate, this is your x bar. So you measure the x bar from y-axis and you measure the y bar from x-axis. This is the simple example. Same concept is applied over here. Same concept is applied over here. Okay. So now we will see the formulas. So the first formula, first is for rectangle. We will start from rectangle. We will see the formulas for centroid. And this is the rectangle. Okay, so this is the width of the rectangle. This is, you can say, depth, B and D. Okay, now I will fix my reference axis. This is my reference axis Y. And this is my reference axis X. This is X axis and this is Y. Okay, now suppose the centroid of this rectangle is situated somewhere here. This is the point where the centroid is situated. Okay, so now the distance of this centroid, the distance of the centroid from y-axis, reference y-axis, this distance, this is called as, this we called it as x bar. This is called as x bar. And the distance of the centroid from x-axis, this distance, this is called as y bar. This is called as y bar. So I will write the formula for x bar. X bar, it is, if this total is b, if this total distance is b, then centroid will be at the center. So this x bar will be b divided by 2, half of b. So x bar is b by 2. Okay. Then y bar. Y bar is this distance from the reference x-axis. This is at the center. So if this total is d, then y bar will be b by 2, and area of rectangle is b into d. This is the area, b into d. This is the area. This is your first figure, rectangle. This is the formula for rectangle. समजलं काय? x बार म्हणजे कुठून कुठलं डिस्टन्स आहे, y बार म्हणजे कुठून कुठलं डिस्टन्स आहे, कळलंय का?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now second figure we will take. It is circle. Remember this formula. There is no derivation for your syllabus. You have to remember this formula. You have to remember it. Next diagram is circle. So we'll draw the circle. This is the circle. Okay. Now you can say somewhere here the centroid of the rectangle is. See, center of circle and centroid are two different terminologies. In the case of circle, the center of circle and the centroid is at the same point. But center of circle ही वेगळी गोष्ट आहे आणि centroid ही वेगळी गोष्ट आहे. सेंटर ऑफ सर्कल म्हणजे काय? तर तुम्ही कंपास घेता, कंपासचं एक टोक त्या सेंटरवरती ठेवता आणि दुसऱ्या टोकाने पेन्सिलने असं तुम्ही सर्कल ड्रॉ करता. ती तुम्हाला रेडियस मिळते, बरोबर आहे? कंपासचं तुम्ही एक टोक ठेवून सर्कल ड्रॉ करता असा. सो दॅट पॉइंट इज सेंटर ऑफ द सर्कल. जिथं तुम्ही कंपास ठेवलेला आहे ते पॉइंट म्हणजे सेंटर ऑफ द सर्कल. आणि सेंट्रॉइड म्हणजे काय? तर या सर्कलचा जो काही एरिया आहे तो एरिया ज्या एका पॉइंट मधनं खाली ऍक्ट होणार आहे त्या पॉइंटला आपण म्हणतो सेंट्रॉइड. ओके. बट सर्कल, you know that circle is having property, it is symmetric about any of the axes. Circle is symmetric for any of the axes. So in the case of circle, the center of circle and the centroid of the circle is the same point. In the case of circle only, circle is the only figure in which you will get the center of the circle and centroid of the circle, both are at the same point. Okay. In the case of a rectangle also, you will get the center at the same point. So now here, the centroid is at this point. Now suppose R is the radius of the circle. Okay. Suppose now the radius of the circle is R and D is the diameter of the circle. R is the radius of the circle. Okay. R is the radius. Then I will draw the reference axis. So this is my reference x-axis. Okay. This is the reference y-axis. This is x-axis. This is y. These are the reference axis. Now what is x bar and what is y bar? So x bar is the distance from y axis. This is x bar. Can you tell me what will be the value of x bar by seeing this diagram? X bar म्हणजे एवढे डिस्टन्स आहे. X bar means radius. Roll number 44, Yash Kulkarni. Switch off your mic. See, don't do the what we can say study like this. Okay, म्हणजे इकडे तुम्ही मोबाईल वरती लेक्चर लावले आणि तिकडे काहीतरी करत बसलाय. It will not be useful for you if you do it in this way. It also disturbs the whole class. So please take care of these things. At least you have to mute yourself. No. Okay. So now here you can see x bar. So you can see this is the center, this is the radius of the circle, this is the radius, and this x bar is the distance from y-axis, that is from this point up to the center. So this x bar is nothing but it is also equal to this radius. Okay. So here I can write my x bar is equal to r, radius. Okay. Now we will see y bar. Y bar is also you can measure from x-axis. This is the x-axis to center. So this is my y bar. This is y bar. So can you tell me again what is y bar?
R.
Y bar is also r. Same. It is same as equal to radius. If this is radius, this is also radius. This is also radius. From the centroid up to the point, up to the circumferential point on the circle, everything is nothing but radius r. कुठूनही तुम्ही मोजा. Okay. So what is the area of the circle then? Area is pi r square. Okay. Or it is also calculated as pi by 4 d square. Another formula to calculate the area of circle is pi by 4 d square. If the diameter is known to you. If the radius is known to you, then it is pi r square. Even though if the diameter is known to you, you can calculate the r. So these are the formulas for circle as well as for rectangle. You try to understand कुठून कुठले डिस्टन्स मेजर करतोय, तुम्हाला फॉर्म्युला ऑटोमॅटिक लक्षात राहून जाईल. पाठ करत बसला तर गोंधळ होणार आहे, कशाचं काय घ्यायचं आणि कशाचं काय घ्यायचं. रेक्टँगल आणि सर्कल, बोथ द डायग्राम्स आर इन फ्रंट ऑफ यू. Have you understood that from which point the distance is measured? Okay, x bar is measured from the y-axis, y bar is measured from x-axis. These x and y are called as the reference axis. This x and y are called as reference axis. And what we are measuring? We are measuring the distance of the centroid of the figure. And we calculate x bar and y bar. Why we need x bar and y bar? Because to locate that centroid, we need its ordinates. So that ordinates we get from this x bar and y bar. Okay. So the third figure is right angle triangle. Right angle triangle. Okay. This is the right angle triangle. This angle is 90 degrees. Now I will draw the reference axis first. This is y-axis. This is x-axis. This is my reference x-axis. This is reference y-axis. Okay. Now the centroid of this right angle triangle may be situated somewhere here. We have seen the formula b by 3 and h by 3 from right angle. घेतला ना आपण UVL चा कन्वर्जन पॉइंट लोड मध्ये करताना. Okay. When we convert the UL into the point load, we have used this formula. In this, we have already used the formula of rectangle and we have already used the formula of right angle triangle. Okay. So now suppose I will give the dimension. This B is the base of the triangle and this H is the height of the triangle. This B is the base, H is the height. So this is the centroid point. So centroid means it is nothing but from a y-axis, this distance of the centroid, this we called it as a x bar. And from x-axis, the distance of this centroid, it is called as y bar. Y bar. So x bar is equal to, I will write the formula here. X bar is equal to, so from right angle, the centroid is situated at a distance of, if this is B, then it will be 1/3 of B. So x bar is equal to B by 3. And y bar is equal to, again right angle triangle is here, so we are measuring from right angle triangle. So y bar is equal to, if this total is h, then this vertical distance between h by 3, then the distance will be h by 3. So b by 3 and h by 3 are the centroids of this rectangle. And what is the formula for area? It is half into base into height. The formula is half into base into height. Okay. Now this triangle, you should tell me the formula. This is again right angle triangle. And you always draw the reference axis in such a way that your figure should come in the first quadrant. कुठे यायला पाहिजे तुम्हाला क्वाड्रंट कळतात ना, ग्राफचे 4 क्वाड्रंट असतात. फर्स्ट क्वाड्रंट मध्ये एक्स पॉझिटिव्ह वाय पॉझिटिव्ह, सेकंड क्वाड्रंट मध्ये जर तुम्ही गेलात तर एक्स निगेटिव्ह वाय पॉझिटिव्ह, थर्ड क्वाड्रंट मध्ये तुम्ही जर गेलात तर एक्स पण निगेटिव्ह असते वाय पण निगेटिव्ह असते, आणि फोर्थ क्वाड्रंट मध्ये तुम्ही जर गेलात तर एक्स पॉझिटिव्ह पण वाय निगेटिव्ह. So only in the first quadrant the value of x is positive and value of y is positive. That is why I am drawing the reference axis from here only. जर मी इथून या पॉइंट पासून रेफरन्स ऍक्सिस ड्रॉ केले तर इकडे माझा ओरिजिन इथं आहे, तर माझ्या एक्सच्या पण व्हॅल्यू पॉझिटिव्ह असणार आहेत राईट साईडला आणि वायच्या व्हॅल्यू पण पॉझिटिव्ह असणार आहेत, जसं मी अपवर्ड जाईन तसं. ओके, सो दॅट इज वाय वी आर टेकिंग आवर रेफरन्स ऍक्सिस ऍट द कॉर्नर ओनली हियर, ऍट द लेफ्ट हँड साइड कॉर्नर, ऍट द लेफ्ट हँड साइड बॉटम कॉर्नर. दॅट इज व्हॉट इज द रिझन. नाही तर तुम्ही मला विचारू शकता ना, मग इथंच का घेतला रेफरन्स ऍक्सिस, इकडं का घेतला नाही, असं येऊ शकतं ना. एक्स ऍक्सिस असं ड्रॉ करा आणि वाय ऍक्सिस असं व्हर्टिकल घ्या, चालतं ना असं पण, नो प्रॉब्लेम, इट इज ऑल्सो करेक्ट. बट जर तुम्ही तसं केलं तर तुमची ही जी डायग्राम आहे मधली रेक्टँगल, ही कुठल्या क्वाड्रंट मध्ये येते हे तुम्हाला बघत बसावं लागेल आणि त्याच्या अनुरूप तुम्हाला प्लस मायनस साईन द्यावे लागतील. ओके, सो इट विल बिकम व्हेरी टीडियस. So that is why, to simplify the things, always keep your figure in the first quadrant. आता बघा हा रेक्टँगल आहे, सॉरी ट्रायंगल आहे, नॉट रेक्टँगल, इट इज अ ट्रायंगल, राईट अँगल ट्रायंगल. ह्याची हाईट एच आहे, ह्याचं बेस बी आहे, सगळं आहे. मला आधी पहिलं माझं व्हॉट इज माय फर्स्ट जॉब, माय फर्स्ट जॉब इज टू ड्रॉ द रेफरन्स ऍक्सेस. ओके, and I should draw the reference axis in such a way that my figure should come in the first quadrant. My figure should come in the first quadrant. मग मी कसं ड्रॉ करायला पाहिजे सांगा मला, कुठल्या कॉर्नर पासून ड्रॉ करायला चालू करायला पाहिजे रेफरन्स ऍक्सिस. आता मला सांगा, आता मी ड्रॉ करतो बघा. These are my reference axis. This is reference axis y and this is reference axis x. This is x axis, this is y. बरोबर आहे का?
नो सर,
Why?
सेकंड क्वाड्रंट मध्ये जातो.
Now if you see, this is your y axis, this is x axis. Here your y values are positive, but your x values are negative, as it is coming in the, coming in the, what we can say, negative side in the second quadrant. मग तुम्हाला ते एक्सचे कोऑर्डिनेट घेताना सगळे मायनस मध्ये घेत बसावं लागतात. सो ते आपल्या डोक्याला जास्त ताप होते तसं केलं तर. म्हणून काय करायचं, फिगरचे रेफरन्स ऍक्सेस ड्रॉ करताना ही काळजी घ्यायची की तुमची जी डायग्राम आहे ती कुठल्या क्वाड्रंट मध्ये यायला पाहिजे, फर्स्ट क्वाड्रंट. इट शुड कम इन टू द फर्स्ट क्वाड्रंट. सो व्हॉट आय विल डू नाव, आय विल फर्स्ट इरेज दिस. ओके, आता बघा फर्स्ट क्वाड्रंट मध्ये येते का नाही डायग्राम. वाय ऍक्सिसला मी इथनं उचलून काय करणार, इथं लावणार. Okay, I will keep over here, and then I will draw x-axis again. Now this is x-axis. Now you can see, now this figure is in which quadrant? First quadrant.
First quadrant.
Okay, here from origin the values of x are also positive as you go on the right hand side, and as you go up the values of y are also positive. Okay, so now the centroid is situated somewhere here, and now what is x bar? तुम्ही सांगा मला x bar कुठून कुठं असणार आहे? कुठून कुठं मोजायचं x bar? काय सांगितलं x bar म्हणजे कुठून मोजायचा असतो? x bar is always measured from y axis and y bar is always measured from x axis. मागच्या सगळ्या फिगर बघा. So now here this is the, suppose this is the centroid, then my x bar value will be from y axis up to here. This is my x bar, and y bar from x axis the centroid. This is y bar. So let me know the values of x bar and y bar. Value सांगा मला x bar आणि y bar.
B/3 and H/3.
B/3 आणि H/3. B/3 कुठून असतं म्हणून सांगितलं तुम्हाला? B/3 कुठून असतं? राईट अँगल पासून ना?
Yes, sir.
See here we have taken this B/3, but because I have highlighted here, this is the right angle. From right angle it is at a distance of B/3 and H/3. So here the right angle is at this corner. So your y-axis and right angle is the same point. So your x bar will be directly this value you will get. Now here you can see your right angle is lies in this corner, and x bar is the distance from the y-axis. So this is x bar. Okay. So if you can see, if this centroid is from right angle, the centroid is at a distance of B/3. So this should be B/3. Okay. So what will be the value of x bar? The value of x bar will be B minus B/3, which is equal to 2B/3. समजते? हे टोटल किती आहे?
Yes, sir.
बी आहे. हे टोटल आहे बी. तिथनं राईट अँगल पासून हा सेंट्रॉइड कितीवर आहे ते मला माहिती फॉर्म्युला. राईट अँगल पासून हा सेंट्रॉइड कितीवर असतो? B/3 वर. हे टोटल आहे बी. हे एवढं आहे B/3. मला हे राहिलेलं कॅल्क्युलेट करता येईल. कसं? तर या मी टोटल बी मधनं हे जर B/3 एवढं मायनस केलं तर मला हे राहिलेलं डिस्टन्स मिळेल. सो दॅट इज माय एक्स बार. ओके. सो माय एक्स बार विल बी this B minus B/3. So it will be 2B/3. And now what is y bar? What is y bar?
To H/3.
Y bar is equal to H/3. विचारच करत नाही आपण कुठल्या गोष्टीचा. How it is 2H/3? And why? See here, right angle इथंच आहे ना, ऍक्सिस पण इथंच आहे ना, इथनच मोजायला लागला ना, एक्स ऍक्सिस पासूनच मोजायला लागला, आणि राईट अँगल पण इथंच आहे. सो राईट अँगल पासून H/3, राईट अँगल पासून दिस इज H. So up to here 1/3 H/3. Right angle is here, and y bar is the same distance which we want. So y bar will be H/3. इथं सुद्धा तीच केस आहे. See, this is your H. This is right angle triangle. So this should be at a distance of 1/3 of this H. So h by 3 y bar, which is measured from x-axis. Here also the same condition is there. This is x-axis and here is your right angle triangle. Only the difference will be in the x bar. X bar will change. Okay. Okay. Yes, no, काय?
Yes, sir.
समजलं ना?
Yes, sir.
ओके. कुठून कुठलं डिस्टन्स मोजतोय नीट लक्षात ठेवायचं आपण. when we are calculating x bar, remember that we are measuring the distance from y axis, and when we are calculating the y bar, remember that we are measuring the distance from x axis. Okay, in that way you have to follow. After this, next is the isosceles triangle. Next is isosceles triangle or equilateral triangle. For both the triangles, same formula. Isosceles or equilateral triangle. Okay. This is the triangle now. Let us say that B is the base of the triangle and H is the height of the triangle. B is base, H is height. Okay. Now, first of all, we need to draw the reference axis. So, from where we should draw the reference axis? From which point? कुठला हा फर्स्ट पॉइंट, सेकंड पॉइंट का थर्ड पॉइंट कुठून ड्रॉ करायचं? From this point?
First point.
First point, okay. So from here, I will draw y-axis. From here also, I will draw x-axis. Because I want my diagram to be in the first figure, first quadrant. This is x. This is y. Okay. So now the center of this triangle will be situated somewhere here. The distance of the centroid from y-axis, this distance. The distance of the centroid from y-axis, it is called as x bar. The distance of the centroid from x-axis, here, this is called as y bar. So your formula for x bar, y bar, area obviously you know that for triangle it is half into base into height. Here previous also same formula. Area is equal to half into base into height. So x bar. Now what is the x bar in the case of isosceles triangle? Now you can see this is not a right angle triangle. It is isosceles or equilateral triangle. So in this case, this centroid will be situated on this vertex line. Okay. So it will divide this base into two equal parts. So this will be b by 2 and next will be b by 2. So here your x bar is b by 2 and y bar is same. That is h by 3. If this total height is h, then 1/3 of that is your y bar and half of the base, it is your x bar. This is for isosceles or equilateral triangle. Okay. So for today we will stop over here. In the next lecture we will take the remaining part. And please do see the formulas at the home. बघा परत एकदा काय शिकवलंय काय नाही ते. ओके, दिस इज व्हेरी इम्पॉर्टंट.
सर
हा,
ते ह्याच्या मागच्या ट्रायंगलचं नाव काय होतं?
ह्याच्या आधीच्या का आत्ताच्या?
ह्याच्या आधीचा.
इट इज राईट अँगल ट्रायंगल. काटकोन म्हणत नाही का तुम्ही याला?
हा सेकंड वाला पण त्याचं नाव तेच येते का मग?
कुठला सेकंड वाला?
हा हा तिथं कर्सर आहे तिथं. हा
इथं पण हा 90 डिग्रीच आहे की, हा पण राईट अँगल ट्रायंगलच झाला की.
फक्त तुम्ही ते कळवा म्हणून ते असं सांगितलं ना दुसरा हे करून.
हा पण राईट अँगल ट्रायंगल आहे, हा पण राईट अँगल ट्रायंगल आहे.
ओके सर.
ह्याला उलट जरी करून काढलं तरी पण तो राईट अँगल ट्रायंगलच राहणार. ओके,
ओके सर.
म्हणजे हा बेस ठेवला आणि हाईट या बाजूला काढली अशी आणि असं जरी जोडलं तरी तो राईट अँगल ट्रायंगलच झाला. Whenever you find one angle as a 90 degree in a triangle, then it is called as right angle triangle. एक कुठलाही अँगल जर 90 डिग्री असेल त्रिकोणामध्ये तर त्याला आपण काटकोन म्हणतो. दॅट इज राईट अँगल ट्रायंगल. ओके, so this is right angle triangle, this is also right angle triangle. And in this triangle you can see there is no 90 degree angle. इथं कुठं काटकोन नाहीये, तर ह्याला आपण आयसोसिलियस और इक्विलॅटरल ट्रायंगल म्हणतो. ओके, आयसोसिलियस ट्रायंगल म्हणजे काय, तर दोन बाजू, ही बाजू आणि ही बाजू सेम असते. आणि इक्विलॅटरल ट्रायंगल म्हणजे ऑल थ्री साइड्स आर इक्वल. इन आयसोसिलियस ट्रायंगल टू साइड्स आर इक्वल. In equilateral triangle, three sides are equal. Okay.
ओके सर.
So now today, what is the date today? 2nd March.
2nd March.
Yes, sir.
2nd March 22 PM. Okay, roll number 1,
Present.
2,
Present, sir.
3,
Present, sir.
4,
Present, sir.
5,
Present, sir.
6,
Present, sir.
7,
प्रेझेंट सर.
8, 9,
Present, sir.
10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14,
Present, sir.
15. Roll number 15, 16,
Present.
17,
Present, sir.
18, 19,
Present.
20,
Present, sir.
21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present.
29,
Present, sir.
30,
Present, sir.
31, 32, 33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36,
Present, sir.
37, 38,
Present, sir.
39,
Present, sir.
40,
Present.
41, 42,
Present, sir.
43,
Present, sir.
44,
Present, sir.
45,
Present, sir.
46, 47, 48, 49, 50,
Present, sir.
51, 52,
Present, sir.
53, 54,
Present, sir.
55, 56, 57,
Present, sir.
58, 59,
Present, sir.
60, 61. Okay, so absent roll numbers, I will call the absent roll numbers now. If your roll number is there in the absent list, then only you can tell me. Okay, otherwise assume that you are marked as a present. Okay. Roll number 15, 15, 18, 31, 41, 47.
47 present, sir.
47 is present, okay. 49, 51, 55, 56, 58, 60. Okay, so these are the absent roll numbers for today's lecture. In the next lecture, we will see the remaining formulas.
Sir,
हाँ,
second and third topic चे MCQ.
सेकंड आणि थर्ड ना, हा मी टाकतो, घेऊ की
Second,
टीचिंग डायरी मध्ये अपलोड करतो.
sir,
First चे
question
केले-
पण करा मध्ये तुम्ही.
काय झालं? आवाज परत एकदा बोलताय का?
केलेत ना?
आवाज तुमचा कट व्हायला
केले
लागला.
का म्हटलं?
कॅन यू रिपीट इट अगेन?
ना?
I think you are not in the proper range. I will upload these MCQs of second unit and third unit in the teaching diary. Lecture is also pending. I have not uploaded all. I hope today evening I will do it. I will upload the MCQs. You will get all the MCQs from there. Small PDFs are there. You can download that PDF and you can see the MCQs. Okay.
Okay, sir.
Okay. Okay, so today we will stop over here. And one more thing, today I think midterm test is there for EM.
Yes, sir.
Okay. So at 5:45, any one of you can call me, because
Okay, sir.
I may have the meeting, so I may forgot to drop the question paper for you. Please remind me at 5:45. Okay.
Okay, sir.
Okay.
Okay.